In this video, in the Universe Sandbox simulator, I'll try to create an unusual planetary system around a brown dwarf, an object that can't be called a full-fledged star. We'll add several different worlds here, ranging from a red-hot lava planet to a massive gas giant with rings, and we'll even try to create a planet with conditions suitable for life. This entire system will be named the Noctaris system, and the main star of this system will be a brown dwarf. To create a brown dwarf, I'll take the planet Jupiter, place it randomly and stationary here, and immediately name it Noctaris. This brown dwarf will have a mass of 40 Jupiter masses, and its radius will be roughly a bit larger than one Jupiter. I'll set it to 1.07 of Jupiter's radius, and as we can see, the temperature is starting to rise on this object. The temperature on it has settled at 477 degrees Celsius, but that's not enough. In the view settings, I'll turn off this artificial light. For now, this brown dwarf doesn't really shine much, but there is a little trick in this simulator. The age shown here is 4.6 billion years. If I set the age to, for example, 1 billion years, then the system will start to heat up. So the simulator thinks the object is younger and it will be hotter, something like that. And in the end, the temperature on this brown dwarf settled at 945 degrees Celsius. And now I'll adjust its colors. I'll remove many colors here and add new ones, and you'll see how it changes. So in the end, I added these colors. I don't know if you noticed any major changes, but anyway, it had to be done. And I'll increase the rotation period on such an object from 9 hours to 15 hours. Now I'll start adding planets. There will be 5 planets in this system, and the first closest planet will orbit at a distance of 0.015 astronomical units. I'll name this planet Ignis. This planet will have a mass of 0.5 Earth masses, and so the radius turned out to be 0.83 of our planet's radius. The temperature on such a planet will be 427 degrees Celsius. And by the way, you can see how it's already become so molten. You can clearly see the brown dwarf here. It's very close to this planet. Next, I'll adjust the visual appearance of this planet. The low elevations on this planet will be lava. I'm applying this value and now we have lava, so to speak. There you see right here, looking like some flowing liquid lava. And the middle elevations on this planet will be this exact color. And so the planet is already looking pretty good. I can also increase the contrast. Oh, look at that! I think I'll actually leave it at the maximum. It looks gorgeous that way. This planet will have a thin atmosphere composed of carbon dioxide. I'll set the value to 0.001 of Earth's atmosphere. And here, as you can see, the pressure value has turned out to be quite low. This planet is going to be tidally locked to the brown dwarf. I'll do that, and as you can see, the orbital period and the day on the planet match perfectly. The axial tilt of this planet will be 1 degree. I've assigned this planet this specific orbital color scheme, and it will have a small eccentricity of 0.01. This planet will also have its own tiny natural satellite. I'll place it at a distance of about 10,000 kilometers, and it will, yes, orbit very close to this planet. I'm going to set the color of its orbit just like this, and give it the name of Ignis 2. As for the size, this moon is going to be exactly 0.05 Earth radii. There won't be an atmosphere on this moon, but the average temperature will be about 300 degrees Celsius. This moon is orbiting very close to this planet. I'll speed up time to check the orbit's stability and see if it gets torn apart. It is being torn apart. So I did place it a bit too close after all. Oh well, I'll have to clear all the fragments and move it a bit further from the planet. The orbital period is currently just over 4 hours. I'll make it say 6 hours, and I'll restore its radius since it lost it, back to 0.05 Earth radii, checking for stability. Oh well, now it's outside the Roche limit. The moon isn't being torn apart and seems to be orbiting the planet stably. I'll speed up time even more. And yes, as you can see, everything is stable now. Yes, you can see that due to its proximity to the planet, the moon has stretched out a bit. Well, that's my plan, for it to orbit close to this planet. And now I'll descend to the surface of this planet. This is what its moon looks like from the surface. And this is the brown dwarf itself. If you take off the space glasses here, it will be this bright and beautiful. And this is how its moon glows in this mode. Now the next planet in the system will orbit at a distance of 0.03 astronomical units. The planet will be named Virex. Its mass will be 0.09 Earth masses. The radius turns out to be almost 1 Earth. Now I'll brighten the planet up a bit. We see the simulator gave me an ocean planet, but I have a different idea. I'll have to remove all the water from here, even the ice water. Here I'll have a sort of toxic Venus. There's already carbon dioxide, but I'll also add sulfur dioxide, about 0.1 of Earth's atmosphere. On this planet, the atmospheric pressure will be about 70 atmospheres. The simulator adjusted it here and set it to 67 atmospheres. And because of this, the surface temperature on this planet will be about 427 degrees Celsius. Let's look at the atmospheric composition. We see there's a lot of sulfur dioxide and a lot of carbon dioxide. Well, basically, you get the idea. Next, I'll hide the atmosphere and set up the clouds. I'll make the clouds denser here, set a storm, and replace this cloud type with these ones. There, that's more clouds. And the color of these clouds won't be white, but like this. And look at what a truly toxic planet we've created. I will now turn everything back on and restore the realistic lighting. This planet will have an axial tilt of 3 degrees, and its day will be close to tidal locking. Our orbital period is 233 hours, so I'll set the day to about 213 hours. The orbit color for this planet will be like this, and the eccentricity will be 0.02, and this planet won't have any moons. Next is the turn of the following planet, and this planet will be at a distance of 0.06 astronomical units. I'm going to turn this planet into an oceanic world with life. You'll see. The mass of this planet will be 1.2 times the mass of Earth. I'll add an Earth-like atmosphere, setting the pressure and composition presets. Look how everything's changed. And I'll also immediately add a magnetic field of 1 Gauss here, so we see the atmospheric components have been added. There's oxygen, nitrogen, and other elements of Earth's atmosphere. The planet looks a bit dim due to the faint light from the brown dwarf, so I'll do this. The temperature on this planet will be about 15 degrees Celsius. Actually, let's go with something like 11 degrees. By the way, I turned on the vegetation and city lights display, and vegetation appeared instantly. Cool. And now I'll add water. Lots of water for this planet. There it is, appearing now. I need to flood roughly 80 or even 90% of the land. As you can see, it looks something like this at the moment, but I don't really like the current height map, so I'll swap it out for a completely different one. Let's try planet 7, for example. Oh, that looks a bit better. And I'll adjust the sea level again. Oh, just take a look at that. Now that's much more like it. Let's leave it right about there for now. And look at how beautiful it turned out. It already looks quite good. But if we add some Earth-like atmospheric haze, it'll be even better. I also decided to change the ocean color. It'll be like this. And the color of the greenery too. And here's the result. What do you think? Now I'll turn on realistic lighting. And this is how the planet looks. On this planet, a day will last 28 hours. The axial tilt will be 20 degrees and the orbit color will be this. The eccentricity will be 0.005. You're probably wondering where the habitable zone is for this star. I'm turning it on, but unfortunately the simulator doesn't show the habitable zone for brown dwarfs. But just so you know, the habitable zone is roughly here, where our life-bearing planet is. Let's check the orbital stability of these 3 planets. As you can see, everything orbits stably. There are no issues. I'm back at the life-bearing planet and I'll add a moon to it. The moon will orbit at a distance of exactly 100,000 kilometers. I'll give this moon a white orbit immediately and officially name it Lyra. This moon will be approximately 0.25 times the radius of Earth. The temperature there will be about minus 40 degrees Celsius. It won't have an atmosphere, but I'll give it a slightly different terrain color, like this. I'll do this so we can get a good look at its surface. And we can crank the contrast to the maximum for a more varied surface. Well, it looks really quite good. I've brought back the realistic lighting. Let's take a look at this life-bearing planet, where we can see the night lights of the cities. Truly wonderful. And this is how the moon Lyra appears from right here. I'll descend to the surface of this life-bearing planet. This is the view of Lyra from the surface, and there's the brown dwarf Noctaris. But if you take off the cosmic glasses, the atmosphere seems to vanish. So, that is our view of the brown dwarf. Let's also take a moment to check the stability of the moon's orbit around this massive planet. I'll speed up the flow of time quite a bit. As you can see, the orbit fluctuates slightly, but it's basically stable and stays aligned with the parent planet's orbit. The orbit is just slightly elliptical. Well, that actually makes it all feel much more plausible. Next up is the 4th planet, and I'll place it at a distance of 0.12 astronomical units. This planet will be a mini-Neptune type, and I'll call it Caelum. The mass of this planet will be about 8 Earths. An atmosphere consisting of helium and hydrogen. Now I'll make it brighter. This is the preset the simulator gave me, but I'll change it and it'll have 3 different colors. The first color will be like this. I'll add 2 more right away, since I need 3 colors. The second color will be like this, and the third color will be like this. So basically, it'll be a mini-Neptune with shades of blue. Regarding the contrast, look, if you crank it all the way to the max, it actually turns out even more beautiful. So I'll leave it like that. Since this planet is already quite far from the star, its average temperature will be minus 84 degrees Celsius. The axial tilt of such a planet will be 15 degrees, and I'll make the day 15 hours long. Oh, look how it flattened out immediately. Wow, let me speed up time even more. Should it really have flattened that much at 15 hours? That's crazy. Okay, let's increase this value to 25 hours. Oh well, let it be at least like this. This planet planet will have this orbit color, and the eccentricity will be 0.03. Now I'll switch back to realistic lighting, and if I do that, the planet becomes kind of greenish, as you can see. I'll even add a bit of exposure here, and you can see for yourselves how the brown dwarf's rays change the surface clouds on this planet, resetting the exposure to the normal value. Well, what can I say? The planet is already very far from the star, so very little light reaches it here. And if you look at it this way, you can see where the brown dwarf is, and you can see the neighboring planets a bit over there. This planet will of course have its own moons. I'll place the first moon at a distance of 172,000 kilometers, and there'll be another moon orbiting at about 273,000 kilometers. I named the first moon Lyra, and its radius will be only 0.1 of Earth's radius. In kilometers, that's 637 kilometers. It'll be very cold on it, around minus 180 degrees Celsius. Now I'll make it brighter and change its appearance. I'll change its mid-altitudes to this color, a sort of cold grey blue, and I'll turn up the contrast higher. And so this is how this moon turned out, though it won't have an atmosphere. Now the second moon will be named Caelum. Its size will be 0.07 of Earth's radius. In kilometers, that's 446 kilometers, and the temperature on it will be about minus 200 degrees Celsius. It won't have an atmosphere either, but I'll change its appearance. I'll set it to custom here, and the appearance changes immediately. Well, okay, that's cool basically, but I'll change its mid-altitudes to this color, and in principle it turned out quite interesting. And I won't forget to increase the contrast. Oh, that looks more beautiful. Now I'll turn on realistic lighting, and this is how the brown dwarf illuminates it. I'll also change the orbit colors for the moons. And now, let's check the stability of their orbits. I'll speed up time quite a bit. As you can see, everything's rotating stably, and the last fifth planet will orbit at a distance of 0.25 astronomical units from the brown dwarf. This planet's mass will be half of Jupiter's. The planet will be named Kronis. It's going to be a cold gas giant like this. Now I'll make it brighter and adjust its appearance. It will have 3 different colors. The first color will be like this, the second color like this, and the third color like that. I'll also increase the contrast, and let's evaluate it. Look, it turned out pretty cool. It looks nice, although maybe the contrast here is a bit much after all. Let's set it somewhere in the middle at 50%. Well, it seems to me like this will be better, and it's going to be very cold here. The average temperature here will be about minus 154 degrees Celsius. On such a planet, a day will be about 10 hours as the planet changes. But at least it didn't stretch as critically here as on the last mini-Neptune. Everything is actually quite decent here. The axial tilt of such a planet will be 25 degrees. And I'll also add rings to this planet. And so it looks wonderful. Very similar to Saturn, but not exactly a carbon copy. I'll turn on realistic lighting. Well, with this lighting, it looks interesting like this. I'll give this planet an orbit color like this, and the eccentricity will be 0.045. Now I'll add moons to it, make it brighter, and the first moon will orbit somewhere here. I'll put the second one somewhere here, and the third one will be the furthest out here. For all these moons, I'll set up orbits like this with an inclination so they match the planet's equator, and I'll just give them all orbit colors like this. And now the first moon. It will be named Noctaris. Its size will be 0.15 of Earth's radius. In kilometers, that's almost 1,000 kilometers. The temperature on it will be minus 120 degrees Celsius as it's close to the planet and gets heated by tidal forces. You can see for yourself, it's been stretched a bit like that. There won't be an atmosphere here either, but I'll change its appearance. But the average elevations on this moon will be like this. And I'll also tweak the contrast. Well then, that's quite good. Now the second moon, it will be named Oral. Its radius will be 0.12 of Earth's radius. That's 765 kilometers. The average temperature on it will be minus 150 degrees Celsius. Also, such a massive gas giant is quite close here, so it heats it up a little from the inside. There won't be an atmosphere, but here I'll also change its appearance, make it custom. And the average elevations here will be this color. And so this is how the appearance turned out. I'll name the third moon Valor. Its radius will be 0.08 of Earth's radius, or 510 kilometers. The temperature on it will be minus 170 degrees Celsius. There won't be an atmosphere, but there will be a custom terrain setting. I'll change the average elevations to this color and increase the contrast to the maximum. And so this is how this moon turned out. Not bad. Now I'll turn on realistic lighting, and well, it's become so red. By the way, I forgot to add contrast to the second moon, Orel. If I bring it to the maximum, then look, it turned out more beautiful. And this is how it looks under realistic lighting. The rings basically rotate stably around the planet, as do the moons around the planet. And overall, I managed to create such a stable system. This is the system I ended up with around a brown dwarf, with all sorts of unusual worlds. Do you think such a system could actually exist in reality? Share your thoughts in the comments below. And be sure to leave a like if you enjoyed the video. Thank you very much.